All right, let's talk about something wild. What if there's a concept, straight from the bizarre world of quantum physics, that suggests you actually can't be deleted from existence? It's called quantum immortality, and honestly, it's one of the most mind-bending ideas in all of science.
And look, I know this sounds like total science fiction, but it's not. This is a very real, very serious debate that physicists are having right now, and it's all rooted in one of the most successful theories we've ever come up with, quantum mechanics. So a promise of immortality. How could this idea possibly work? Well, to even begin to wrap our heads around it, we've got to dive deep into the super weird rules that run the show at the tiniest, most fundamental levels of our universe. Here's the thing. Down at that fundamental level, it's all about randomness. It's not like kicking a marble, right? You kick it the same way every time, it lands in pretty much the same spot. But a particle, like an electron, whoa, do the exact same thing to it 10 times, and it could pop up in 10 totally different places. It's all governed by what physicists call a wave of probability.
Okay, so worlds within worlds. This deep-seated randomness, it's been a huge headache for scientists for almost a century. And it has sparked this massive debate about what quantum mechanics is even telling us about the nature of reality itself.
So you've basically got two camps in this great quantum debate. Think of them as the linguists versus the literary critics. First up, the linguists. Their take is pretty much shut up and calculate. They see quantum mechanics not as a story about what's real, but just as an incredible tool, a set of rules that lets us make predictions with insane accuracy. For them, that's enough. But then you've got the literary critics. These are the folks behind what's known as the many worlds interpretation. And they say, oh no, the theory is the story. And what a strange story it is. They believe that every single possible outcome of a quantum event actually happens. It just happens in its own brand new, completely separate, and equally real world.
I mean, just let that sink in for a second. Every time a tiny particle has a choice, say go left or go right, the universe doesn't pick one, it splits. A whole new universe branches off where it went left and another where it went right. And you? Oh yeah, you split right along with it. There's a version of you experiencing each of those branches.
All right, the ultimate experiment. So the linguists would say, okay, that's a cool story, but if we can't see or touch these other worlds, how can you ever prove they're real? It's a fair point, but there is a famous thought experiment to test it, made popular by the physicist Max Tegmark. There's just one tiny catch. You have to be willing to risk your life. They call it quantum Russian roulette. Here's how it works. You've got a device, a machine, hooked up to a quantum particle. If that particle is measured in state A, and let's say there's a 20% chance of that, nothing happens. You're safe. But if it's measured in state B with an 80% probability, a device kills you. Instantly. No pain, no awareness, you're just gone.
Okay, so you run the experiment. Now, if the many worlds view is correct, the moment that measurement happens, the universe splits. In a huge majority of those new worlds, 80% of them in this case, you die. But in the other 20%, you survive. And this right here is the absolute core of quantum immortality. Just think about it for a second. You can't experience being dead, right? There's no you left in those other branches to register, oh, I died. So from your own subjective perspective, you will only ever find yourself in the branch where you survived. The first time you survive, fine, maybe you just got lucky. But what if you do it again and again, say 100 times? In a single universe, the odds of you surviving that are, well, they're basically zero. That number on the screen is just, it's astronomical. So if you're still standing after 100 rounds, it's not really luck anymore, is it? It would be some seriously powerful evidence that many worlds is correct. You survived because you had to.
All right, a survivor's burden. So, does this actually mean you're immortal? Well, before you go trying any daredevil stunts, physicist Sean Carroll offers a pretty sobering reality check on all this. What Carroll argues is, hey, wait a minute, we shouldn't only care about the one version of us that gets to survive. All those other versions of you, the bazillions of them that die in this experiment, are just as real as the one that lives. And we should be bothered by their fate right now, before the trigger is ever pulled. So, competing realities. It's really important to remember this. This whole wild idea of quantum immortality, it completely hinges on the many worlds theory being the right one. And trust me, it is definitely not the only game in town. There are other powerful ideas out there. You've got hidden variables theories.
which basically say particles do have definite locations. We're just not clever enough to know what they are. And then there's spontaneous collapse theory, which suggests these waves of probability just collapse down into one single reality, all by themselves, randomly, without needing an observer at all. And here's what's fascinating. Some of these alternate theories, unlike many worlds, make specific predictions that we can actually test. Spontaneous collapse, for example, predicts that energy isn't perfectly conserved, that a tiny bit of heat should be generated in the process. And scientists are out there, right now, looking for it. If they find it, the case for quantum mortality gets a whole lot weaker.
So, this brings us to the big question. The universe's glitch? Because ultimately, all of these wild competing theories are wrestling with the same fundamental problem. What is actually real at the quantum level? You know, what's happening when we're not looking?
In the end, quantum immortality isn't a promise. It's really a profound question. Is our existence just a single fragile thread? Or is each of us just one conscious branch on this infinitely vast, ever-growing tree of realities? Is this a glitch in the universe's logic, or a fundamental truth of our existence? Join the discussion below. Let us know what you think.